Alright guys, so here we have a problem. It's basically a circuits problem. So for this problem, it's chapter 28. We're given a circuit here, and we're asked to find the current throughout each resistor. Okay, so this is Mastering Physics, Physics 184, and here are the answers already, just in case you guys want to make sure that I'm correct. I want to make sure that my answers are correct. I'm not just being you lies anyways. Before we start this problem, the biggest thing to know for this problem is one of the tables you can find in the book. If you have, it basically says series and you have parallel. So resistors, right? These resistors, like right here, these two are in parallel, and this one, or if you combine these two, and this one would be parallel, or this one and this one, or they're not parallel. But basically, I'll show you guys once we get working here. So you have the current, which is I, and the voltage, the change in voltage is delta V. The series for I would be the same for the current. And then if the voltage will be, well, you just have to add them up if they're in series, the voltage. And if they're in parallel, the voltage will just be the same. And then the current, you have to add them. You see, they're opposites of each other. That's one big thing you have to memorize, or you can just write down on your cheat sheet in order to do this problem. So first thing we want to do in this type of problem is we want to work backwards. So we just want to find the equivalent resistor. So basically, if we have like a battery here, and then that's still 24 volts, right? We can reduce this picture down, right? One by one, just a little bit. So we have a capacitor here, and then, oops, I did not mean to. I want to draw straighter lines, better lines, right? Capacitor here, something like this. Yeah, it's getting okay. This is equivalent, right? So this will still remain as 2 ohms. Okay, this is gonna be 8 ohms. Can't really write that symbol out. That's still 4 ohms because we didn't combine anything here, right? That's an ugly 4 ohms. And then these two we did combine. So how do we find the equivalent resistance for these two? Well, basically these two are in parallel. So if they're in parallel, you have to use the equation here, where the equivalent resistor is equal to the inverse of 1 over that resistor. So it'll be 1 over 6 plus 1 over 12. And then you take the inverse of that. Well, I'm going to type this in the calculator real quick. You're going to get 4, so the equivalent resistance can be 4, okay? So we're done with this stuff. Now we can actually further reduce this picture down. Let's go ahead and draw a battery out again. 24 volts. Just gonna have one resistor there, one resistor there. Oh, it looks like I missed one. That's a resistor right there. Okay. That's connected. So if they're in series, just add them up, right? So 4 plus 4 is just gonna be 8 ohms, and this is still gonna be untouched, and this is gonna be untouched. Now, as you guys might see, these two in parallel. So again, we can find the equivalent resistor of these two. So still 24 volts. Resistor here, resistor here, complete the loop. So again, we have to do the 1 over 8 plus 1 over 8 and take the inverse of that. So 1 divided plus 1 divided by 8. That will give you 4. Okay, so that's just going to be equivalent. The equivalent resistor is going to be 4 ohms. Alright, I'm erasing this because we're going to use this space later. You guys will see why. This again will remain as 2 ohms as that was untouched. And as you guys can see, these two are in parallel. So we can just add these up to get the equivalent resistor of these two. So we're going to have the battery again, which is always going to be 24 volts. And then we're only going to have one resistor. And that's just going to be 6 because we just added it up. So now let's go ahead and work backwards. Now we got that all equivalent resisted, right? We got to find the amps so we can work backwards. So right at the bat, we know that this is 24 volts as well because it's the only resistor, or yeah, it's the only resistor in the loop passing through the battery. So you guys know the equation E equals to negative IR. Okay, so I is the current, R is the resistor, so that we could find I just by dividing R to the other side. So R is equal, or I is equal to E divided by R, which is a negative sign, but you're always going to have a positive current, right? If you get a negative current, that means your assumed direction is backwards, so it's either going clockwise or counterclockwise in the loop. So, in this case, it doesn't really matter because it doesn't ask us which direction the current's going in, but it's good to know so we can keep our currents straight. So anyways, we can solve this, right, because we have everything we need. So we can get I, the current, is equal to 24 volts divided by the R, which is 6 ohms, or that's also V over A, I'm sorry. It's V over A. These will cancel and get amps, right? So 24 divided by 6, well, that's just 4 amps. And again, so if you guys noticed, it was going to be negative, so that means my assumed direction, I'm just going to assume it's going this way. It doesn't really matter for this problem. So we get 4 amps, okay? So now we decide to break up this problem, and like I said in this table above, now they're in series, right? So what happens in series? Well, as you guys can see, the voltage, you have to add them, but what stays the same is actually the amperage, right? That's the word for amperage, right? So this will still be 4 amps, and this will still be 4 amps. Now the question is, what is the voltage? The voltage, right, the same equation right here is just going to be E, so E is equal to negative IR, but your voltage, we don't even really care about the sign in this problem. Okay, it's pretty safe to assume everything is positive for this problem. And the charge goes out of the positive side, so it's probably going to be going this way, right, the current. So anyways, it's just some multiplication now, so E for the current, the voltage for the top one is going to be 2 times 4. So, I mean, the units, right, the units of an ohm is volts over amperage times 4 amperage. You see the amps cancel out, so you get 8 volts, so that's 8 volts right here. And then the same here, 4 times 4, that's a 16. Right, so 4V over A times 4A. I'm not going to write this out every single time, but this is just so you guys get the point. It's going to be 16 amps right here. Or not 16 amps, my bad, 16 volts. So now we have this one. Now we can keep working backwards. As you can see, we only changed the resistor, the vertical resistor here. This one stays the same. We didn't touch it at all. So this is still 8 volts, and this is still 4 amps. Now, we changed this one to in parallel, so what stays the same in parallel? As you guys can see, the voltage stays the same in parallel. So this is gonna have 16 volts, and this is gonna have 16 volts. Okay, so what is different is it's gonna be the I, the current, right? But again, the current is gonna be equal to, right? It's gonna be the volt divided by the resistance. So I is equal to 8 divided by, or 16 divided by 8, which is the resistance, and they're the same for both ones, so we want to do this once. 16 divided by 8 is 2 amps, so we get 2 amps here and 2 amps here, right? Alright, and then you can see 2 plus 2 is 4, and that's what we have coming in, 2 amps coming in, so we don't have more current coming out of it nowhere, so that's a good way to check yourself too. And now we can even break this up even to the main picture now, right? So what's the main picture? Now we just added another one right here, right? I mean, we still have to break it up into one more. I guess I missed one here. We can just write on here actually. So this is actually picture number 1. Okay, this is picture 2, picture 3, and so on. Okay, so we added another resistor right here. Like I said, these ones stay the same because we're not touching these ones right now. So that's still 2 amps. This one's remained untouched. This is still 2 amps and 8 volts. So in series, as you guys can see, the amps remain the same. So this is 2 amps, and this is 2 amps. So all we need to know is the voltage, and we know the voltage is equal to IR. So we just multiply these two again. So that's just going to be 8 volts here and 8 volts there. Yep. So they're in series. If you add them up, 8 plus 8 is 16, and which is the same on this side, right? So that's how you can confirm that. Again, I think the last one's pretty straightforward now. We just broke the bottom two up. So we can write everything we have here. Since we're only looking for the current, I'm just going to write the current since this is a smaller picture. So that's going to be 4 amps here. As we found, this is 2 amps here. The top one remains unchanged, 2 amps. Okay, so we have to find this one. So we broke this bottom one. We're just looking at this one now, right? So when we're looking at, so we have what remains the same in parallel? The change in voltage, right? The voltage remains the same. So we know that this is 8 volts. That's 8 volts. So again, to find the current, it's just going to be the voltage divided by R. So it's going to be 8 divided by 6, which is 1.3 amps. And then 8 divided by 12, which is just going to be 0.67 amps. And that's it. So answer 1, answer here, answer here, answer there. So checking our answers, I at 2 ohms is 4, which is correct. Current at current at 4 ohms, that's right here, which is 2, which is correct as well. The current at 12 ohms, 0.67, which is correct, and the last one at 8 ohms, which is right here, 2 amps, which is all correct. So that's basically how you do it. Just like I said, you gotta break it up into the most simplest circuit and then just work your way backwards. Just follow the textbook, guys. Hope that made sense. I hope I'm doing this the right way, but that's just what I learned from the textbook. Thanks, guys.